come to the point. What is meant by interference? Yes, basically we try to understand here. Light is in the form of wave only, and when we consider two waves from the same source, or number of waves from the same source, or number of waves from the different sources. So what is the interference actually? Interference is more related to the amplitude or intensity. And there are certain conditions satisfies these waves in the medium, then we observe dark and bright fringes or darkness or brightness in the medium. How it is and why it is the question. And what are the conditions for the interference? More correctly, we can say that when two waves under certain conditions come together, the combination of it, we observe maxima or minima. That means maximum intensity or minimum intensity. And intensity is related to the amplitude, and that's why the algebraic sum of the amplitudes is nothing but in that medium is nothing but the interference. How interference observed? Due to algebraic sum of the amplitudes of the two waves in the medium, and later on we see under what condition, which condition is required for the interference. So this is the very fundamental thing, and then we definitely understand what is meant by interference. You have studied this thing in 12th standard, and here again we are revising this thing for better understanding the phenomenon of interference of light. We can define the interference, no problem. It is simply an addition of amplitudes of two waves, and resultant amplitude is the result of two waves. Of course, algebraic sum is greater than that of the one of the wave, or less than that of the single wave. Depends upon this, there are two types of interference patterns. Number one is constructive interference, and number two is destructive interference. So constructive interference and destructive interference, these are the two types of interference pattern. What happens in the constructive interference? In the constructive interference, addition of two waves or algebraic sum of the two waves, is nothing but the addition of amplitude which is greater than that of the single. And this is known as constructive, but there is a condition. Source must be coherent. You have studied this. Then what is meant by coherent and non-coherent source? From the coherent source, all the waves are emitted, they are in phase. And in the non-coherent sources, all the waves are emitted, but they are out of phase. They are in disturbed manner. And basic condition for the interference is source must be or waves must be coherent. Means all the waves are in phase. Considering this fact, when interference is there, constructive and destructive interference we observe, and in constructive interference, bright point or maximum amplitude we observe, maximum intensity we observe, and in the destructive interference, the minimum intensity we observe, and all of you see here the interference, types of interference, that is constructive interference. In this constructive interference, this is the single wave Y, this is Y1, and Y1 plus Y1 is resultant wave. In this resultant wave, the amplitude of this resultant wave is greater than that of the previous wave or the single wave, and therefore this type of interference is known as the constructive interference. Now, destructive interference. In this destructive interference, this is again wave Y1, and here Y minus Y1 means this phase difference here, phase difference is 0, here these two waves are out of phase, and therefore the resultant wave is like this. Amplitude of this wave is less than the this Y or Y1 wave, and therefore this type of interference is known as destructive interference. Now, considering light is in the form of wave, and then only we can say that the interference pattern on the basis of coherent source we can explain, and there are two types of interference: constructive interference and destructive interference. So these 2 points are very important for the understanding of interference. Now, all of you know that constructive interference, there is one condition, path difference is equal to n lambda, where n is equal to 0, 1, 2, 3, 4. In first standard you have studied this, and therefore the very basic thing is that delta is equal to n lambda. So n lambda, where n is equal to 0, 1, 2, 3, 4. For 0, delta is equal to 0, and therefore path difference is 0, and hence this formula is very important for you for this constructive interference, that is path difference must be n lambda, where n is equal to 0, 1, 2, 3, and hence phase difference is equal to, we know that delta is equal to 2 pi upon lambda into path difference. Therefore, the phase difference is equal to 2n pi, because the formula is this: delta is equal to 2 pi upon lambda into path difference, that is n lambda for this constructive interference, and therefore 2 pi upon lambda into n lambda. So delta is equal to 2n pi. Again, destructive interference. In this interference, the path difference is 2n plus or minus 1 lambda by 2. So for the constructive interference, n lambda, and for the destructive interference, path difference is equal to 2n plus or minus 1 lambda by 2.